All right, so we have the example problem on page 895 of chapter 29.5, and it's a problem about a proton in a parallel plate capacitor. And these parallel plates are actually disks, which have a 2 centimeter diameter, and they're 2 millimeters apart, and it's a charge potential difference of 500 volts. And so there's three parts to this question. Part A is what is the electric field strength inside and between the two disks. B is how much charge is on each plate. And then C asks if a proton is shot through a small hole in the negative plate with a speed of 2.0 times 10 to the fifth millimeters per second, does it reach the other side? If not, where's the turning point? So, we'll start with part A. Part A is asking for the electric field strength inside between the two disks. And you just use V equals ED and then divide out the D and you get E equals V over D. And we have both those values because our charge difference is 500 volts and our distance between the two plates is 2 millimeters. Plug that in, you get 2.5 so instead of the fifth volts per meter. And that's the electric field strength inside and between the two disks. And part B is for asking for the charge on each plate. And we know E equals eta over epsilon naught. And eta also equals the charge over the area, which is charge over pi r squared because it's a disk. And you can manipulate those equations to get Q equals pi r squared times epsilon naught times the electric field. And we have those numbers, pi and epsilon naught are they're constants. And then the electric field we got in part A, and we know the radius. So we get 0.7 nanocoulombs for the charge on each plate. And then the final part is part C, asking for if the proton is shot from the 0 volt plate to the 500 volt plate, because the 500 volt plate will be repelling that charge. So it's wondering if it'll have the speed, that initial speed to get to the other side, or it'll be turned around before that. And so that's what we're going to find out. You basically just use the conservation of energy equation, which is K final plus U final equals K initial plus U initial. And we know that for problems like this, we use potential energy U is equal to E times V. And some of the values are going to equal 0, so we end up with 0 plus E times S over D times the difference in voltage, change in voltage. And on the other side, we just have 1/2 of V squared. And then you just manipulate the equation again. We're looking for that distance S, how far it's going to go. And plug in the values we know, and we end up with 0.84 millimeters. So it doesn't actually even get halfway to the halfway in between the two plates. It's turned around before that. So yeah, that's the end of the problem.